Then we're going to finish up 5, 6, mostly looking at logarithmic equations. But and then tomorrow you're going to spend time reviewing why I'm not here, and then we'll take the chapter 5 test on Wednesday. There's no quiz. There's no quiz tomorrow. There's a sub tomorrow. Mrs. Schultz. Adam Schultz's mom. When a living organism dies, its carbon-14 decays. The half-life of carbon-14 is 5,730 years. So the amount of carbon-14 remaining at that time, T, is given by m of T equals P times 0.5 raised to the power of T over 5,730, where P is the mass of the carbon-14 that was present initially. The function m can be used to determine the age of fossils and some relics. So it is determined that a mummy has lost 32% of its original carbon-14. When did the person die? So P is the mass of the carbon-14 that was present initially, and m of T is the mass after T years. Okay. Well, right now, all we know is that the mummy's lost 32%, right? Okay. So if the mummy started with 100, the mummy would now have 68, right? If the mummy started with 1, it would now have 0.68, right? Okay, 32% is gone, 68% remains, whatever the amount is. Okay. The thing is, they don't give us an amount, so we could actually pick a number. Okay. Right. And the easiest number to use would be the fact that if you start with 1, you have 68% left, right? 32% is gone, 68% is left. So we're going to do that. So m of T in this case is going to be 0.68. And that equals 1 times 0.5 raised to the power of T over 5,730. Now, the reason we want to use 1 and 0.68 is because then we don't have to divide by the coefficient of the exponential function. Otherwise, we would have to. All right, so if I would use 168, I would have divided by 100 first, which means I would have had 0.68 over here anyway. So now this is just a problem where you have to take the log of both sides. Just one of those exponential problems. Raised to the power, yep. So when I solve this equation, we would find out that this person is approximately 3,188 years old. Well, you could use either one. The common log or the natural log is fine. So this is just like those problems we were just solving. First part is just setting it up. Okay. Now we're going to solve logarithmic equations. We've gone through all of the different types of exponential equations, some where you can make the bases the same, others where you've got to take the log or natural log of both sides. So when we're solving logarithmic equations, the first thing we want to do is we want to make sure we want to simplify so you only have one log or natural log on each side of the equation. Okay. Or, I mean, the best thing would really be to not have any logarithms, or you only have logarithms on one side instead of both, because then you can change it to exponential to solve and like that. So here we have logarithmic equation, log on both sides. So I have two of them on the left side here, so I want to simplify that so there's only one there. So I can write this as the natural log of 4x minus 1 times x plus 2 using the power rule, or the product rule. And on the other side, I can write that as the natural log of x squared. So we FOIL this left side. We get 4x squared plus 7x minus 2. Now we have the natural log on both sides. So what can I, okay. Right, because if I have the natural log of something is equal to the natural log of something else, then those two things better be equal for this to be a true statement, right? So then since that's true, then all I need to do is work with 4x squared plus 7x minus 2 equals x squared. So I just need to set that equal to 0 and solve. It's a quadratic equation. Unfortunately, though, in this case here, when you get equal to 0, this quadratic equation cannot be factored. So since it cannot be factored, then you have to do complete the square or the quadratic formula. So if we do the quadratic formula, we get, let's see, negative 7 over 2 times 3 plus or minus the square root of 7 squared minus 4 times 3 times negative 2. What's 49 plus 24? 73. Okay. So there's my answer, right? Because the square root of 73 cannot be simplified. Right? That's the answer? No, it's not the answer. Okay? Because I have not, this is what x equals. That's what I did right here. When I find the quadratic formula, I'm solving for x. How many answers are there here? Two answers, okay? There's negative 7 plus, negative 7, 6 plus the square root of 73 over 6, 73 over 6. And there's negative 7, 6 minus the square root of 73 over 6. Now, we're talking about a logarithmic equation here, right? When you're working with logarithms, there are restrictions on logarithms because the domain is not all real numbers. Has to be greater than 0. Okay? So if I take, now is this, let me write this one better. So is this number here positive or negative? What's the square root of 73 approximately? Well, okay, around 8 and it's between 8 and 9, right? Okay, periods between 8 and 9. So if I do negative 7 plus something bigger than 8, I'm going to end up with a positive number, right? So the one on the left side is positive. The one on the right side here is definitely negative, okay? If I put the negative one into the right-hand side, I'm trying to take the natural log of a negative number. Cannot do that, which means that this one here is extraneous and does not work. So my answer then would be just that one there. So when you're doing the solving logarithmic equations, you have to check to make sure that your answers work. And basically all that check is determining whether it's positive or negative. Yep. Number 10. Not exactly.
How's that work though with 8 minus, is that actually 8 or is that something?
That is the number 8.
So you add it to the natural log.
Okay. So what should we do here first?
Add the natural log of 2x.
Right, we want to get the natural logs on the same side then. If I can do that, I want to do it. So we're going to add natural log 2x plus 1. So if we're adding, that means we are actually, okay. So we get 2x plus 1, that quantity squared, right, is equal to 8. Now, here I have a logarithmic equation. And what did you say, Caleb? Nope, you said something else before that. Okay, we can move the 2 in front. So let's do that. Let's move the 2 in front. It's a good call. So we get 2 natural log using the power rule. Right. So we can divide by 2. We all have our moments, Caleb. The blind squirrel finds a nut once in a while. Okay. Now, all right, that's good. That's good work because now I've simplified this to a single logarithmic equation, natural log of something equals 4. And what we want to do now is change it to exponential. If I solve it so that I have a single logarithm on one side and just a constant on the other, I want to then change it to exponential form. In other words, what's the base here for natural log? E, which means then that 2x plus 1 is equal to e to the 4th. I just changed it to exponential form. And that got rid of the natural log. And I now have a very simple equation to solve. Subtract 1. So we get 2x equals e to the 4th minus 1. And then divided by 2. Which is what? 26.79. Okay. So here we have the exact answer and the approximate answer. Okay, because sometimes when you get into more advanced mathematics, they really don't care about the exact answer. They just want to know approximate answers. Because anybody can put that in their calculator and find the answer. Okay, that's the point. No, e to the 4th minus 1 over 2, which is approximately 26.799. You're still using 3 decimals when you do the approximation. Okay? Yep.
0.598, so it's 0.60 minus 1 divided by 2 equals 26.
You don't round until after you're all done.
Next to 2.
Okay? Don't round until I get done. Okay, one more. We did a couple with natural log. Let's look at one with a common log. It's been almost time to go since we got in here. It's Groundhog Day. All right, so this problem is almost exactly like the last one, except we're using the common log instead of natural log. Since I only have 2 logarithms, and so I can get them on the same side, which is what I'd really like to do first of all. So I'm going to add log of x minus 1 to both sides. So since we're adding, that means multiplication. So what kind of equation are we going to end up with here when it's all said and done? Exponential, but we're going to end up with a quadratic equation. And whenever you end up with a quadratic equation, how many answers do you get? 2. So if I get more than one answer, then I'm going to need to check to make sure they work. Okay. In this case here that we just did, this answer 26.799 is a positive number, and in my logarithms up here, okay, there was no negatives in there, so we didn't have to worry about extraneous solutions. So we get the log of x squared plus x minus 2 equals 1. All right, when we FOIL that. Okay. So now I've simplified the logarithm as much as I can. I'm going to change it to exponential form. And what's the base for the common logarithm? 10, so this is 10 to the first power over here. So we have hopefully a simple quadratic. X squared plus x, subtract 10, we get, oh good, minus 12. So this is something that I can factor, which is going to make it so much easier to do then. X plus 4 and x minus 3 equals 0. So we would get negative 4 and positive 3. And then I need to check my answers. If I put negative 4 here, we're going to be doing the logarithm of a negative. Negative 4 over here, we'll have the logarithm of negative. That can't be. So the answer is just that x equals 3.